to this, I have explained uh, mostly on equation and broadly one segment of an equation, that is linear equation, and this probably the last episode or chapter on linear equation. Here I will explain some of the uh, essential and useful property or characteristic of an linear equation, taking a general um, form of an linear equation. And in the future, if I find anything interesting, then definitely I will bring it to you, so that it will be helpful. But as of now, this could be the last chapter to understand more on linear equation. So let me start with naming it as a chapter 4, and that is on linear equation. Okay, so if I take a general form of any linear equation is ax plus by plus c equals 0, that means this is a this is a very general form of linear equation. Linear equation means it will represent a line. Mostly, if I say in general terms, it will represent a line. Here you can see there are two variables x and y. A and b are the coefficient of x and y respectively. Okay, and c is a constant. Okay, so these are the different parts of this equation. What I would say, x and y are the variables. That means for different value of x and y, this equation will satisfy the same line, which will be represented by this general form of the equation. So that means if it is representing a line with variable x and y, so there could be any numbers of solution of x and y. That means combination of x and y, there could be n number of values for which this equation will satisfy. Here a is coefficient to x, b is coefficient to y, c is a constant, and all together this is a linear equation. Now going further, I want to represent this equation in some specific form, so that I can represent y a function of x. So what I will do, I will bring all the remaining part on right hand side, keeping y function on the left hand side. Further, I will divide it with b to give a specific form where I will see what is y and how it is related to the rest of the terms, means constant and variable. So I can say y is function of x, where the order of x and y both is individually 1. So y is a function of x when there are two variables x and y and both having order of 1. So this is I can, so if I represent it in graphical representation of a two-dimensional axis system where this is x, this is y. So if I represent it, let's say this linear equation is something like that. Now what does it mean? If this linear equation is like that only, what does it mean? If I say this equation is represented by this line, then if I say this is the line, so that means this is y is equal to minus a by b x minus c by b. So this is the representation. Now if I want to bring specific a specific idea of the terms which is related to this equation, if I assume some of the standard value, let me say this is x and y equal to 0 and 0. Now if I put x is equal to 0 in this equation, what I will get? Y is equal to minus c by b. That means this coordinate 0 comma c by b would be somewhere in the y axis, because x is 0 on the y axis and y is minus, because I am assuming c and b and a all are greater than 0 and integer, let's say, and integer. If I assume that, it may be different, but for the sake of the calculation or understanding, I am taking this a comma b comma c are all integers. That could be fractions also, I am not denying, but as of now if I assume these are integers and these are positive greater than 0, leave it like that. I will only assume this is greater than 0, that means all are positive numbers. Then the value of c by b also a positive number, but along with the minus sign it will denote something on the negative axis. So there I can say that line will pass through definitely through the point where this coordinate says is minus c by b. So one is definite. So if I take this, then it would be the correct representation of the equation by saying that for x is equal to 0, b is negative, so that means it is pass through. So this is the one thing. Second thing, it is not parallel to any of the axes, because if it is parallel to any of the axes, other is constant. That means if it is parallel to x axis, so y would be constant, so y could not be a variable, and if it is parallel to y axis, x will be constant, it would not be variable. So it won't make any sense if I say both are x and y are variable, so it must be either this way or that way, any of this, depending on the slope of the slope, that means what the angle it is forming with the x-axis, slope it is forming with the x-axis. So accordingly the line will slant either on this way or this way. Now how do I decide that? What is slope here in the equation? So to understand that, let's say I am coming back to the original equation. Okay, now you have understood where I have arrayed it in somewhere like that, c by b. So this part is the segment cut on the y axis. So this is constant, this is says this way if it is going that way, or if it is passing through this way also, this would be the same thing. So this part wherever I array in the form of y is equal to, let's say, mx plus n, so this part is always the part which will cut from y-axis. So this is always the same thing. Now what about m? What is m here? Now I am coming back to the original equation. Now in this equation, if I assume that if line is passing through, that would pass to several points. Okay. Now two such points, the coordinate is x1, y1 and x2, y2 on the xy coordinate system. Okay. So if I say that, so both, if it is lying on the same line, so both point individually will satisfy the equation. So putting the value of x and y, I will get the equation like that. One of like that, or another one ax2 ax1 plus b y1 plus c equal to 0, because these are constant, it won't change for any value of x and y, only the xy and value. So if I deduct it from the first, so what I will get, a will be common, x2 minus x1 plus b taking common, y2 minus y1, and c will be 0. So that is equal to 0. Now if I say a x, I am keeping y one side, y2 minus y1 is equal to minus a into x2 minus x1. So now taking b upon a and negative sign on this side, I will get something x2 minus x1 by y2 minus y1. Okay. So if I reverse it, I will get minus a by b equal to y2 minus y1 x2 minus x1. Now let's see what does it mean. Now if I am getting this, I just want to put the equation and line like that, and assuming these are the 2 points, this one x1 y1 and the higher point is x2 y2. Now if I join this line and join this line, it will be perpendicular to each other, because this is parallel to y-axis, this is parallel to x-axis, and this part is nothing but, because this total is y2, this one is y1, similarly this one is x2 and this one is x1. So this part individually y2 minus y1 and this part is x2 minus x1. So if I take the ratio of this by this, and this is 90 degree, and if I take this is theta, so tan of theta, that means if I take, because tan ratio is nothing but the perpendicular divided by base, so that is equal to y2 minus y1 by x2 minus x1, which is nothing but I find from the when I have taken the difference of this equation is a by b. So this is tan theta, that means the slope of this line, tan theta, because if I extend it and it is cutting on the x-axis, this angle, because these are parallel to this, so this angle is and this angle are equal. If this is theta, this also theta, so that means tan of theta will give you the slope of this equation, which is equal to a by b. Now if you remember, I have arranged the equation in the form of a by b into x minus c by b, but this I have told, this is this part minus c by b, and now a by b I find is equal to y2 minus y1 by x2 minus x1 into x plus some constant k, say this one I am taking as k. So this part is nothing but the slope of the line. Tan theta is equal into x plus k. Now this tan theta, as it is slope, I am denoting in the form of m into x plus k. So any equation in this form, the coefficient with x would be your slope. Slope means slope. So slope means the line making angle with x-axis is the slope of that linear equation. Now if line goes like that, now then slope would be this much. If slope is this one, then slope would be this much. Now you know tan any angle within this part is equal to between 0 to tan 90 is infinity, 0, that means positive. Tan any angle between 0 to 90 is positive, but tan, if it is going on the second axis, so tan would be negative. So if it is tan, so if slope is coming negative, then I can say the line would be like that. If slope is coming positive, then line would be like that. So I think you have understood this part. Okay, and now I will move to the next part of that equation, that is, how will I decide where, if of similar kind two lines are parallel, intersecting, or coinciding, or you can say merging. Coinciding is a different word. Merging each other. So if two lines are making some distance and not meeting at any point of time and in any side of that, so this will be parallel. That means those lines are maintaining equal distance always. These are parallel. If two lines are moving in the same path, and then it will merge, so this will be merging. Intersecting means two lines will meet at point, in only one point, and never chances of meeting in any other point, so these are intersecting. So this is the general understanding about the lines. But how will I decide if two lines are given, those are intersecting, parallel, or merging each other or coinciding each other? So let's say I am taking two lines of variable a1, means the constant b1y plus c1 is equal to 0. This is representing one line. Another line a2 b2y plus c2. So when I am varying this constant, this line will be different line. This would not be a same line. So what is the relation between these two lines, where I can say that lines are parallel or coinciding or intersecting? So let me make the line in the form I brought it earlier cases. So it would be a1 by b1 x should be c1 by b1, and other one is will be minus a2 by b2 x minus c2 by b2. Now see, two lines, if it is parallel, so that means they will not coincide. This constant part should not be same. That means if I present it in xy path, so if two lines are coinciding, they will cut at x-axis in same point. So if it is not cutting at same point, that means those are parallel lines. Okay. So that means minus C1 by B1 never be equal to minus C2 by B2. Cannot be. Or otherwise, if I bring the similar constant in one side, so B1 by B2 will not ever be equal to, because minus minus will be cancelled out, C1 by C2. So this is the condition where I can say lines are not coinciding, because constant part should not be same. This is the one part. So I rub it here. So the first condition to be parallel, if B1 by B2 not equal to C1 by C2. Now if those are parallel, then these slopes must be equal. So that means if this represent the slope that I have explained earlier, it must be equal, A2 by B2. From here I can say B1 by B2 is equal to A1 by A2. Okay, so this both should not be equal to C1 by C2. So this is the condition where by comparing two lines I can say the lines are parallel, but not from this condition I can say the lines are parallel but not coinciding, okay, or merging. So this is the only condition if it is so. Now this is the one thing. If second case, lines are coinciding, so what would be the change in the condition? This part, because for line coinciding or parallel, the slopes must be same. So that means this part always be same. Only thing, if the lines are coinciding, that means they will cut the same part from y-axis. That will not, because if parallel lines are there, that will cut a different segment. This will cut a different segment. This will cut different segment. But if are coinciding, so that they will cut the same part from the y-axis. So that means that inequality will become equality. So for this case, B1 by B2 is equal to A1 by A2 is equal to C1 by C2. So from this equation you can say the lines are coinciding. So these are the two conditions. Now come to the point where I could say the lines are intersecting. So if lines to be intersecting, so that means the slopes are different. So slope doesn't match. So slope is denoted by A1 by B1 and A2 by B2. So if lines are intersecting, it should not be equal. Okay, so that means A1 by A2 not equal to B1 by B2. Okay, and if I represent it in same xy, there could be possibility that will intersect same or different. Then also it will be intersecting. So I cannot comment on the constant part. Only thing is that they are not equal. This is ratio should not be equal. So if those equations are not equal, so you can understand clearly the difference between the line which is intersecting and parallel, which are coinciding and parallel. This condition always equal, means A1 by A2 is equal to A2 by B2. But for intersecting, this is not equal. Whereas for parallel and intersecting, the constant part is different. So there this part will differentiate those lines. Okay, so if it is given two different line of different concept, different line with different constant, and you have to detect which are coinciding, which are not, which are parallel. From this condition you will able to make it clear that the condition of the required condition, whether it is parallel, coinciding or intersecting. Okay, so this is up to the concepts on linear equation, their applications. Applications would be many. The linear equation can be used for age calculation, or for distance, velocity and time relation, that could be used there also. Then this could be used for your case of, you can say, the linear equation. I can for percentage also we can use the linear equation for percentage calculation, or unitary method also I can use the linear equation to solve the problem. So there are so many applications where linear equation can be used differently to solve the problem. So that's for now. I think that would be a very interesting session for all of you if you pass through all the sessions. So my request is that kindly go through serially, means from chapter 1 to chapter 4 consecutively, so that you will get some continuity in your lesson. So thank you for now. Good night.